And just a few housekeeping facts. So Anika will start in a second presenting the tools that we built on calibration, data handling, and then we're gonna have Q&As after the presentation. You can either put it into the chat or raise your hand and ask live question. And as usual, we also have a code of conduct that I will put into the chat now, just to make sure we have a good atmosphere for our webinars. Great. So without further ado, I would like to hand over the floor to Anika, who is our scientific advisor at AirGradient, I think for probably nearly 3 years now, I guess, something around that, running our co-location projects. And in the meantime, we have a couple of other scientists that she is looking after. And I think the presentation today is really probably the accumulation of a year's time of work that we really try to see how can we make data handling calibrations as easy as possible. But I'm sure Anika will give a little bit more background. So Anika, over to you.
Thank you, Achim. Hello, everyone. Welcome. It's great to see so many known and new faces. And as Achim already mentioned, I want to give you an introduction into the different tools we have to help you with handling air quality data and calibrating sensors. So I think everyone here in this group knows that air pollution is bad for health and for the environment. And there are also many motivated people who want to fight air pollution already since a long time. Air pollution, low-cost sensors are relatively new, and they can help empower organizations, engaged people to advocate for cleaner air. However, they also need some attention sometimes when it comes to data handling, to calibration, and they also, that can become quite overwhelming, especially for people. Not every little municipality or every little organization, environmental organization, has a data scientist in their team. So, data can be quite a lot from low-cost sensors, so it can become quite overwhelming quite quickly. So, for example, if you have a low-cost sensor, the standard, the recommendation is to calibrate it against a reference instrument. So for that, you need to put the sensor next to the reference instrument. Then you need to extract calibration parameters. For example, by performing a linear fit, you apply these calibration parameters to your sensor and you have your calibrated sensor. And what I want to focus on today is exactly this step of extracting parameters. Not everyone is familiar with the linear fit and so on, so that can already be quite complicated. And now we have the advantage of low-cost sensors that they're relatively cheap, relatively affordable. So often you actually have a sensor network to look at data, air pollution data in more detail, to see where are emission sources and where can we work to improve the air quality. So often you have a air quality network and you want to calibrate this, and this becomes even more complicated to calibrate because it becomes a lot of data. So how much data are we talking about? Why do we have these little stripes here now on my screen? Does everyone see them? Okay, I guess we have to live with them. I don't know how to delete them.
Okay, just continue, Anika. I'll have a look there.
So how much data are we actually talking about? So I just give you an example of, I would say, medium-sized sensor network. So let's say you have 30 sensors that you distribute over an area, for example, a little city or town. You let them run for 6 months to also capture maybe seasonal changes. So that's actually medium sized. You have far bigger networks that run far longer. But already this one gives you more than 200 million data points. So this becomes a lot of data very quickly. And yeah, that is not easy to handle, definitely not with Excel anymore. And so I understand that people can feel quite overwhelmed quite quickly with that. So that's why what I say with this calibration can become more tricky when you calibrate a sensor network. And then I want to talk about one more case where you might actually don't have access to a reference instrument. So what do you do then with your sensor network? So these are the three cases where we have developed or are still developing solutions for. So I want to introduce you to these three tools here. Calibration tool to calibrate one monitor very easily. Then the network calibration tool, you can use it actually with or without reference. So that's why I put that in brackets. And then another tool that might help you to improve the sensor network performance if you don't have direct access to a reference. While I have the honor to introduce you to all of these fantastic tools, I was not the person designing them. They were designed by our software team, and especially I want to name Anastasia, who I think did the major part of this work. And you will see that they are very smoothly designed and yeah, so I will walk you through that. And then there's one more tool I want to show you. That's a data visualization tool. That's a little bit less scientific, let's say. It's more exploratory, also really handy. Also saves you a lot of time and data handling. So that's something to look forward to if there are times that it becomes too technical for you. But don't worry, I walk you through as smoothly as possible. So I will start with these three tools here. So let's start with the calibration tool. And the aim of that tool is to align the measurements of your monitor with a reference. So that is basically the classic calibration with a local reference, and that increases your sensor accuracy. You can find it in the main menu of your dashboard. Here it's called calibration with reference. What kind of data do you need to use that tool? Well, since you need to align the monitor with a reference, you need to place them in the same place, your reference and your monitor, for some days, ideally for at least a week if you can. And then I'll walk you through the tool, how you can use it. So basically, all you need to do is put in the data that you want to use to calibrate your sensor. So you have a reference sensor that you can select and a monitor that you want to calibrate. Here, a little disclaimer. Currently, we need to add the reference data manually. Like if you want to add this to your dashboard, you contact us and we help you with that. But we're working on this to do this also automatically. Right. But it's possible. So you have your reference data, you have your monitor that you want to calibrate. You can select a measure. So that can be PM 2.5, but could also be temperature or so. And then you select the period where these two monitors were co-located, when they were standing in the same place. So they were also exposed to the same air. The tool then automatically plots your data so you can have a visual look if everything looks like you would expect it. So here you can see the reference is shown in green. The monitor that you want to calibrate is shown in gray, like before the calibration, the raw data, and then again in blue after the calibration, so after it has been aligned to the reference. It could potentially be that there is a time shift in these two data sets. For this, we've added the function that you can also shift the data in time. And you also see scatter plots. So basically, you plot your monitor to calibrate against the reference. And yeah, and then for every point in time, you get 1 point that says how much measure both sensors. And the closer these points are building a line, yeah, a linear, line, the better they track each other. So there's also, the plot also gives you a measure for that, the R² values. And the R² value can be maximum 1. That means perfect correlation, perfect tracking each other. Yeah, so you see they actually track each other really well, which you also see here. And the closer this kind of line is on this gray line, this one-to-one line, the better the accuracy of the sensor. So what we do with the calibration is to align these dots onto the one-to-one line so that we maximize the accuracy. You can also see that here the RMSE, the root mean square error, is basically a measure for the average error, so the average difference between the monitor and the reference. And you see that this becomes lower when you apply the calibration. Most importantly, so these plots are basically just there for you to visually check that everything is going well. But most importantly, the tool then just spits out the calibration parameters that are needed, that need to be applied to your raw data to calibrate your sensor, and you can also do that automatically. So there's a button, you say apply calibration, and from that point on, you will see calibrated data in your dashboard, and you can also download calibrated data. There is a column called PM 2.5 calibrated, for example, and where you would then find these data. There's one more function in the calibration tool, which is the testing period. You can add a second period, which you don't use to extract the calibration parameters. So maybe you are aware of this training and testing data sets. So basically you have one data set where you train your model or where you extract the calibration period, and then you check it with an independent data set. How well does it actually work? So that's optional, but you can do it. You can add a testing period, and then you can also see that in the scatter plots, you then have blue data points as well. And you can also see, okay, how well do they align with the one-to-one line? Yeah, in these scatter plots, and you can also get a separate RMSE only for the testing period. So this is already the calibration tool. So in the end of the day, you just put in the data, which monitors and which time period, and then you can calibrate them with one click. The next tool is kind of building up on that, but also has more functions. That's a network calibration tool. So instead of calibrating only one monitor, we're gonna calibrate multiple monitors at the same time. So as I said, you can do that with or without a reference. If you don't have a reference, you can still align the monitors with each other, which also helps with the reproducibility, and that makes it easier to compare your measurements if you know that they all measure the same, as they should. But if you have a reference, you can also align them to a reference. You can see that here is already a little sneak preview, let's say, where you have a sensor network, and you see that the lines are then aligned to each other after the tool has been used. Another very useful aspect of this tool is that you can also automatically identify potentially faulty sensors. So maybe if you have a sensor network of 200 sensors or so, there could be some that work differently than you expect, or maybe there's a broken sensor, and the tool can also identify them for you and tell you which ones they are, which ones need some more attention. So what kind of data do you need for this tool? Um, Again, we need to co-locate the sensors. In that case, all of the sensors from your network need to be in the same location, again, for a couple of days, maybe a week, if you can. And if you have a reference, then you place them along. So let's walk through the tool. How does it work? Again, you select the data. So basically, you select the data period where all the sensors were placed together. And you can add all the locations. So what do we mean with locations? Basically the sensor names, which of all the sensors that were involved in this co-location, in all the sensors that were placed together. As you can see, here are several steps that we have in that tool. And every step is also explained with some text to walk you through. But since I am now talking, I haven't copy pasted all the text, but I'm going to walk you through the steps by, yeah, by word. So once you've added your monitors and your time, it will automatically plot the data that you have selected. And that helps you just to understand if you're selecting the right sensors, because it could be that you have many, many sensors on your dashboard and you just select a subset that you place together and you want to make sure that you selected the right sensors. Or perhaps there are sensors on your dashboard that have that you added later, so they actually have no data in that time. So that would also be shown by this visualization. And you can also highlight individual sensors by clicking on them here in the legend. If you are not sure about one, you can see if they are behaving the way you expect them or not. So if you're happy with your selection of sensors, you go to the next step, and that's the correlation check. So I'll show you now the correlation check first for a healthy sensor network. So here we have no faulty or broken sensors in, and this is how it looks then. So all of the sensors are then marked blue, which means they are passing the correlation check, which means that they all follow the same trends and they can all be aligned easily. You can also see that for those who are interested, that we also plot a correlation matrix. So here you see the R² values, the coefficients of determination. These are the ones, the closer they are to one, the better the agreement between each other. And you can see here they're all really high because they track each other really well. They show different scalings basically because this is our testing chamber and there are different sensor models in there or plant tower models. So that's why there might be different scalings, but they all follow the same trends. And yeah, if all sensors are fine and agreeing with each other, the next step, the filtering outlier step, will just tell you, okay, there's good agreement in your network. We don't need to filter out any faulty sensors. How does it look if you do have faulty sensors? For this, I looked up a different data set where we have some sensors that are co-located, but also some that only measure zero values. So I actually don't know if they're co-located or if something is wrong with them, but the system automatically picks them up and marks them as failed because they don't follow the trends that all other sensors follow. You see that also in the matrix. Here, okay, they would be marked and you would see, okay, they have much lower R² values. You can then decide to annotate them. So later you can still find in the dashboard which ones are the ones I need to look at closer, where the like kind of the problem sensors. And if you're then happy with that, you can continue to the next step where the system filters out these monitors automatically because it doesn't make sense to align them to the rest of the sensors if they don't, follow the same trends, if they don't correlate. And this is how it looks then. The red sensors were filtered out and you get a list again of all the sensors that showed poor correlation. And then we go on to the next step. We still want to align the sensors to each other. So we go to the next step and we need to select one monitor where all sensors are aligned to. You can either let the system do that automatically, so it basically selects the one that it thinks is most representative, but you can also manually select the location that you want all sensors aligned to. So if you have a reference within this network, then of course you would take the reference and then all sensors will be aligned to that reference. So in this, that will also be plotted again, visualized, and the reference that you select will be shown in green. If you're happy with that, then you can go to the next step where it aligns all sensors to your reference monitor. And now you have nicely reproducible sensors that all measure the same when they're exposed to the same air. For every sensor, the system calculates some parameters, these calibration parameters that can be applied to each sensor. And you can also download this table for later documentation, but you can also apply the calibration to the sensor network. And then, as before, from that point on, you would have these sensors calibrated with this tool in the dashboard and also when you download them. So this is our network calibration tool. And last, I wanted to also talk about the background calibration tool. So what is this? This is basically if you have a sensor network but don't have access to a reference instrument, you cannot collocate them all together. What do you do then? For this, I need to go a little bit into theory. So we have, actually, when we talk about air pollution, we can say that it is built out of two components. A regional component that changes relatively slowly and is also relatively constant over large areas. And on top of that, you have local emissions. So basically, a truck passing by or a barbecue grill or something like that, they will, add extra pollution to that. And then the sum of these two, this is your local pollution that you would measure at a sensor's place somewhere in your network, somewhere in your town. But if you have many sensors, you are able to extract this regional background here, this baseline basically. And because this is the same over large areas, you can potentially use that for calibration. So I'll show you what I mean at an example. So here we have the village Pai in Thailand. And there's a sensor network, an AirGradient sensor network distributed across the entire village. So every individual sensor measures local and regional pollution. But when you plot them all together, you are able to extract this regional background. And if we look in the region where Pi is situated, and we're trying to find the next public reference where you can basically download the data, that would be in Mae Hong Son. And that's about 50 kilometers away from Pi. So it's not so easy. I think there are also mountains in between. It's quite a ride there. It's not so easy to collocate your sensors with this reference, but this reference also just measures the regional background. So if you are able to extract it from here, we can compare the two, the two parameters basically. I'll walk you through how that works in practice, and then I hope it gets a bit clearer. So this is the background calibration tool that we use for this. This is still work in progress at the moment. We're still looking for testing data, but there's kind of already a skeleton that I will show you. The aim here is, as I explained, to align the measurements of your sensor network to a remote reference. So maybe a public reference that is a bit further away. So then we focus on regional pollution. And also the end game is basically to increase the accuracy. What kind of data do you need here? Well, the beauty is that you don't need to have an extra step. You can have your sensors deployed where you usually want to have them, just your sensor network, put them into the locations where you want them. And there you can apply this background calibration tool. But it is, of course, useful to check the consistency before you distribute your network. So basically, before you uh, distribute your sensors to the individual locations, it would be nice to place them all together and make sure that they all measure the same. And if they don't measure all the same, you can use the network calibration tool to align them to each other. So how does the background extraction tool work? Again, we need to put in the time where we want to extract the background and also from which location. So basically here you select this network in Pi, for example, and this is then how it looks. So you have, as you can see, all sensors are more or less following the same baseline. And then on top of this, you have all these localized pollution spikes. And the tool then automatically, with one click, you can extract the baseline. And and then you get this baseline, which you can then compare to a reference location. Here, I actually didn't put the reference location of Myeongsong because, well, I tried it. I already calculated it through and it works. But once we built the tool, actually the reference location Myeongsong was broken. So I couldn't take screenshots from the real reference data in this tool, but it works. And for now, I just show you how the concept works with one of the sensors in our network. So the tool then compares this extracted baseline, which is the regional pollution in pi in your network. It compares it to the reference, which should be the regional, which should also measuring regional pollution. And then you can use this again to align the network to the reference. So again, you can create a scatter plot, which of course now doesn't build a perfect line anymore, since they are not perfectly measuring the exact same air, but you can see that it's still kind of a linear relationship that you can use for the calibration. The tool then shows you before and after, so it's your raw network and how does it look when it has been calibrated, so the background has been aligned to the reference. And yeah, and if you're happy with that, you can again extract the calibration parameters, which you apply to the entire network, and you can apply them to all locations, again in the dashboard. And then from that moment on, you get these calibrated values. All right, so I hope you're all still awake and could follow so far. I'm looking forward to questions to these tools. Last but not least, I promised to you that we wanted to also talk about the visualization tool. And this is much more intuitive, I find, and really helpful just to explore your data, to get a first feeling for your data. And I actually just today looked at a few locations with the visualization tool and picked up a few, let's say, interesting or peculiar aspects of the data I looked at, just to show you what you can explore with the visualization tool. So all in all it does is it visualizes the data of a selected sensor or several selected sensors over a time period that you select. So you get a timeline. How do your concentrations change? And that is really, really helpful, for example, to find weekly or seasonal patterns. You don't need to think about anything when it comes to which data to look at. You can just look at any data you want. It's also in the main menu, quite high up of your dashboard. So there are two modes actually. It's a single parameter mode, That means that you can only look at one parameter, for example, PM2.5, but you can compare different locations. So this is, for example, my dashboard, my personal dashboard, which I show you now, some peculiarities. This is when I was still living in Italy, and we look at the temperature data of different rooms in my house. And here you can, for example, see how the different rooms heat up differently depending on where they are regarding to the sun. So the red line is the living room, and that's facing east. So here the temperature spikes first. And then my office is facing west or southwest, so the temperature spikes later. And it's the same facing as the kitchen, but the kitchen has some kind of winter garden or so, some kind of greenhouse effect, I would say. So it got really, really hot in the kitchen. And you can really nicely see all of these, interesting phenomenons. You can observe your house. For people who are interested in data, there are like many cool features you can find in the data. So here, so just to explain you the tool, here I use the parameter temperature and I look at 4 different locations. Now I can also look at CO2, and then I can see my daily routines. I can see when I sleep in my bedroom, then CO2 goes up because I'm sleeping there, and I can see when I'm working in the office because then the CO2 spikes there. And now people will think I'm a very lazy worker. But remember that the sun came around during lunchtime. So that's, of course, when I opened the window because it got too hot. So I was actually longer in the office, believe it or not. And then just to give you another example where we maybe look at seasonal patterns. So this is again Pi, our village. And this is an entire year that I've plotted, also very easily with this visualization tool from May to May. And you can really see the buildup of air pollution, which kind of spikes then here in the burning season, where you have agricultural burning. And if I then look at the multi-parameter mode, so that's basically you can only select one locations, but you can select different parameters at the same time. So I selected one of these locations here. You can see it's the same pattern. PM spikes up and peaks in March. And then you see the humidity that I added. So humidity is not the same as rain, of course, but it kind of shows you that there is like a wet season and then there is a dry season. So the buildup of air pollution, of course, has something to do also with the dry season. There's no rain to wash out the dust from the air, so that allows the buildup. And then, so the dry season plus agricultural burning then leads to this spike here in March and April. So it's a very intuitive tool, this visualization tool, and it's really fun to play around with data to find patterns. I invite everyone who has already AirGradient sensors to play around with it. And that's already the tools I wanted to show you. I hope that I could, that these tools that I just introduced to you, that they help people with being overwhelmed with data and kind of help them to save time and which they then can use for fighting against air pollution, for advocating for cleaner air, and less for data management, data formatting, analysis, and so on. Here's just a little overview, which tool you should use when. So depending on if you have reference data and how many sensors you have, we have different tools to use. And also, again, for the visualization tool, basically you can always use it. Even if you don't want to save time, you can procrastinate a lot by looking at the data. All right, that's all from my side. I'm looking forward to your questions. Thank you for your attention.
Thank you, Annika. I think this was really amazing. Also for me, even I know the tools already to get such a great overview. we already have a number of questions. Before we start, I want to announce something. So we started actually working on a portable, wearable, open source air quality monitor. And Altair from our team put also a small questionnaire into the chat. So if you're interested in that topic, fill that in. But this should not distract from the topic today, which is obviously about, data handling and make it easy for hopefully pretty much everybody. So let's start with, I go through the order of, we got the questions in. So from Sanjay was the first one. When network sensors are gathered in one place for calibration, won't other factors at that location affect their measured performance? For instance, if a location where calibration is happening has higher humidity and temperature than the normal measurement location, the calibration applied may not be entirely accurate.
Yeah, that's a good point. That's why let's say the golden standard is to calibrate your sensors in the place where you also want to use them. So basically, you should try to cover the same conditions, for example, relative humidity or temperature, as you will expect then during your deployment. That's not always possible, but yet I think it's worth, getting as close as possible. So depending if you have a reference or not, even if you don't have a reference, I would always, if you're planning to deploy a network, I would always recommend to put them even just on your kitchen desk or on or office desk and let them run for a while just to make sure that they all measure as expected and that they all are consistent. But yeah, the golden standard, if you can realize this, is to to calibrate your sensors in the same conditions as you expect for your deployment.
Great, thank you, Anika. Next question is actually about our mobile apps. I also already gave a quick answer. So we launched Android and iOS apps just, I think, 1 or 2 months ago. There's a small bug in the Android app, which is actually already fixed. We just have to push it to the Play Store. Maybe Altair could also put in the links into the chat for these 2 mobile apps if you're interested to use them. They have a great map of, I think, 40 or 50,000 monitors. It's open source as everything we do. All right, so let's continue. Search for the next question. How do you add the reference if it's not AirGradient? Maybe I can quickly answer that. Anika mentioned it already. So we are building an interface, for example, to OpenAQ. In the meantime, we actually already have it done, but it's not in the dashboard. You can just contact our support team, and then we can pull in that data. We can already interface with a lot of third-party sensors, low cost as well as reference, and then we can integrate that data. Then from Duncan, a question for a PhD level student for a PhD level study. Do you think that having the low cost sensors co-located for a longer period of time, for example, a year, to get a calibration protocol for all seasonal changes would be a good idea?
Good point with the seasonal changes. Again, if you have a long deployment, then the seasons might change and you don't cover all calibration, all conditions. But it's also perhaps not, the data value you get if you collocate, let's say, 50 sensors all in one place with a reference just to get a calibration protocol. I think maybe you can do something more useful with these sensors. What I would recommend is to collocate them for a while. If you want to be thorough, maybe for a couple of weeks. And then you can do some deployment and leave some of, like a subset of your sensors, leave them next to the reference. So then you can also see how they react if the seasons change or if their potential drift. I don't expect it, but yeah, you can kind of control for all of these factors. But you could already use the other part of your sensor monitoring network. You can use it maybe to answer other questions. So that's how I would go about this.
Thanks, Annika. Then we have a question from Van. Great to see Thai people in here as well. So when doing co-location, is there a protocol of how far each one of the network sensors need to be? The government says that sometimes co-locating sensors pick up different pollution profiles due to wind directions. And then also, what's an acceptable range of R squares? If it's not exactly one, like what
Mhm.
should you aim for?
Regarding the distance between the sensors, yeah, as close as possible. Like with co-location, I really mean that they are all like on one table, for example, or along one on one roof or so. The I think if they are like within a few meters, or let's say within 20 meters or so with each other, I wouldn't expect that they are exposed to two different pollution. But this is your aim, of course. You want them to be all exposed to the same concentration, to the same air, to the same pollution. So what you can also, or what you should also pay attention to is that there is no direct emission source right next to your network. So if you put them on the roof, for example, make sure that there's not a chimney or an air conditioning outlet or so right next to it, so that only some sensors are affected and the rest not. You want them to be exposed to the same air. But if there is, I don't know, if there are 10 centimeters between the sensors or half a meter, I don't think that makes a big difference. And yeah, what's an acceptable R squared? There are for some pollutants like PM 2.5, you get some guidelines. The US Environmental Protection Agency says 0. 0.7 is a target for R squared. Yeah, I think I agree with that, but mostly, especially for the agreement between sensors, it's actually higher.
Great, thank you, Annika. Then we have another question from Sanjay. I'm relatively new to the AirGradient community. Can I use the dashboard and visualization tools to review data from sensors in other areas not in my account? Actually, I can answer that quickly. So yes, so you can actually add as many users as you want to your dashboard. And they could then, if they already have their own dashboard, then they can basically switch dashboards. So you log in one time and then you can see other people's dashboard. You can give also certain permissions. You can only give them read access, for example, so they cannot mess up your data or anything or change your calibrations or something like that. So that's possible. So from G. Simons, we have a question. What about seasons, winter minus 10 degrees versus summer 25? Is 1 week calibration enough? A similar question. And then also, is the 2 PMS average used to calibrate if one PMS sensor fails? What will happen?
All right. Yeah. So to the seasons, again, we want to try to cover all conditions that you also have in your deployment. So if you want to deploy your sensors for several seasons, then it would be nice to also calibrate them yeah, in the same conditions. You could try to use, well, yeah, you could follow the same protocol. You calibrate them initially, also for more than a week if you have the chance, and let some sensors stand at the reference, and then you can update your calibration parameters if they significantly change when your temperature changes, because like that's why you need to make sure that they all behave the same first with this network calibration tool when you align them all to each other. And if you know that they all measure the same, then you can also kind of extrapolate from your subset that you have still left at your reference. You can then use the same factors to extrapolate to the other sensors. And then what you asked with the 2 PMS average, I think you mean for those sensors that have two modules integrated, two PM modules, identical ones, in one monitor. I think at the moment we use the average to calibrate, but this is something that we're actually still discussing because exactly what you say, if one sensor fails, it would be nice to be able to use the other one. And for this, it would be nice to have both modules individually calibrated. So that's actually what we're in contact with our backend developers and firmware writers, that we have them calibrated separately. But it's a bit complicated, but we don't need to go into technical details.
Yeah, maybe let me add it's work in progress. So it's
Yeah.
definitely gonna improve on this one. So then we have from Ian question, is there a way to calibrate a single sensor against known non-air gradient sensors? For example, manual entry of reference data.
Yes, I think that's what we already said. You can add non-air gradient reference data to the dashboard. That's actually encouraged, like the calibration tool is for that. You should use real reference data from officially recognized reference stations. Currently, you need to still kind of manually enter it. You cannot do it by yourself. You contact our team and then we help you to get this reference data, which is non-air gradient, into your system, into the dashboard.
Yeah, maybe just adding, I think we also have on our list some kind of upload function, but it's just more difficult because I think all of you know this already problem with different timestamps, and that's where it starts. But it's definitely something that I think a couple of people would like to see. So it's on the list. Then we have from Ellen, thank you for the presentation. What software or programming language do you use to create a visualization tool? So front end is Angular, and then we use Chart.js for the charts. From Paolo, okay, that's I think more a comment. Multiple parameters mode, great addition. I have been using Soho Analytics to do a similar job. Thank you, Paolo. Then, okay, Altair put in the presentation. From Victor, is there a way we could calibrate the other sensors like CO2, temperature, relative humidity? CO2 sensor readings is very important, but is affected by humidity.
Yeah, that already works for temperature and relative humidity. I think CO2 not yet, and I'm not too sure. But generally, yes, you can in the calibration tools select the parameter that you want to calibrate. CO2 is a little bit complicated because you also have an automatic baseline correction. But that's actually something we're looking in a little bit more systematically right now. So nothing speaks against adding that to the calibration function if it is not already there. So it's on our list for sure.
Great. Then from Ahmed, a gradient Android app is quite impressive. A little correction under information icon, the PM breakpoints are labeled as AQI breakpoints. Yes, there will be a lot of things coming in the app. So remember what you currently see is version 1.0, and we are heavily working on it. So this will go up very, very steep, and we will fix these bugs. Actually, I just submitted an update in the iOS store just before this. So iPhone users are gonna get something quite soon. From Chia Srinivassan, I have 3 questions to pose here today. This is just for near future for any kind of solutions. Volcano emissions will corrupt the sensor readings. I hope nobody is living near a volcano, but yes, it's probably the case. Ability to get different pollution elements in air pollution and how they affect the children, teens, middle-aged, and older people and their respiratory problems, like in New Delhi. Able to decompose the pollution caused by chemtrails that we see in the world today and how it affects people's health. Maybe I can quickly take this because I also peek a little bit on the time. So I just had a couple of calls actually with the WHO recently on how can we bring more like health-related issues into the basically the platform, I would say in general, because obviously in the end of the day, it's more about what happens to your body than what molecules are swirling around in the air. But obviously that's a very, very complex topic, but it's something that we feel we really need to look into. And this is something that we have started. So, and one of the vehicles that we want to use are actually the mobile applications that we localized already in more than 10 languages just to reach the population with better health information. Good. From Olivier, I think there's no questions. Thank you for the compliments. From Alice, thank you, Anika and AirGradient team, for your third type of calibration. Over what range distance do you think a network sensor can be used to calibrate AirGradient sensors? Like, what's the maximum distance?
Yeah.
Yeah.
That is a fantastic question, and I think that's not so easy to answer. That's why we're testing it at the moment, and we're looking for data sets. I think it depends on factors like topography, like if there are mountains in between, what the wind direction is, how complex the emissions are in the area, and so on. So I cannot really answer this question. I remember that I once looked at data from London and from Paris, and I was surprised that they still agreed relatively well, at least on the day that I looked at. So it can be quite far, but I would also not be surprised that you look at smaller differences at distances sometimes, and you do find larger differences. So yeah, I think it's a little bit looking at how well does your background still or your baseline still correlate with the reference. Yeah, a bit of trial and error. That's something we're still testing. It's a new method. Yeah, I cannot fully, like, there's no one answer to that.
Good. Question from Paolo. If we have a single co-located monitor at certain locations, can we calibrate a scattered network batch?
If we have single,
Or maybe Paolo, you could quickly explain.
yeah.
Maybe Anika has a difficulty understanding exactly the question.
Hi, everybody. Thanks for a great presentation. Just for example, we have a number of monitors. 8 of them are co-located with government units. The rest of our network is scattered all over. Is there a way to shortcut my bringing them all to one place and calibrating? If I calibrate at one of the reference stations, can I average calibrate across the network?
Yes. Well, theoretically, yes. As I said, the only thing is that you should make sure that they all measure the same, ideally, now for other people setting up networks in the future. Before you distribute them, it's nice to put them all together, make sure they all measure the same. And then you can also use a subset and extrapolate or use the same calibration parameters for the rest. If you now, in your situation, you still say you have eight monitors that you can calibrate. So if you see that they all have more or less the same calibration parameters, then you can, I would assume, okay, if it works for these randomly selected 8 monitors, then it will probably also work for the rest. So then you could apply them to the rest as well.
Yeah, those were the original monitors that we put in the co-location program that we started over a year ago. So those are still all with the government monitors.
Great, yeah.
I haven't tested the tool yet, but I'm just trying to work out if there's a shortcut.
Yeah, well, try the tool with these collocations, and if you find that it's the same or similar parameters to calibrate them, then I would assume that you can also use them for the rest.
Great. I think we have 2 more questions. One from Victor. Is there a chance in the future that AirGradient can partner with a reference sensor provider so that we just work with AirGradient sensors, locus, and reference all together? We have a Pallas in in the office, and they have actually a cheaper model, which is the kind of reference grade called AQ Guard. And we are trying to set up a kind of case study where we use that device as a reference and with a network around with local sensors. And this is something we want to then present at the BAQ conference in March in Bangkok. So yes, we are looking into this, but we also want to be obviously like provider independent. But we see the need to try to have like an easy way to integrate reference stations.
But maybe also what we can say is we're creating an interface with OpenAQ. So there's lots of reference data there, which you could then also pull into the dashboard.
Exactly. So Blandhauer says the sensors are in-house calibrated. Why need to calibrate again? That's a good question. Anika, you want to give a short answer on that one?
Yes, if you put a new plant hour sensor next to a reference instrument, you will find that they don't measure the same. That's a short answer.
Yeah.
So you can still increase the accuracy.
Sometimes we are surprised when we talk with sensor module manufacturers how little they know or want to actually say about their own monitors. Maybe a very, very last one. How often should you calibrate sensors, Anika? Any quick answer on that?
Yeah, basically for PM, there's not really drift, but keep in mind that you want to cover the same conditions. So if you use them a whole year, make sure that you also cover the seasonal changes, perhaps by keeping one sensor next to the reference instrument. But theoretically, you could let them run for 2 years or so. It's not that they are affected by drift.
Great. Then I want to wrap it up. We are just exactly on the hour. Thank you so much, Anika. I think this was a great presentation. I think we also have seldom so many people joining us. I think it really means you hit the right topic here. So many thanks. And if there are still questions, just reach out to us. On our website is a support form. Then we can also directly assign the ticket to Anika, and then we can continue the conversation there. We also gonna actually have another forum next week, I think on Thursday, about the toolkit that we developed together with UNDP. So the invitations will come to the same newsletter like you got this invitation. We just didn't want to overload you. So we were waiting with having this forum first, and then we're gonna have another quite interesting one, I believe, next week with also an interesting panel discussion there. Yeah, so many thanks, and have a great day or evening wherever you are.
Thank you. Bye-bye.